Next up, we have Tyler from New South Wales Health Pathology, who's going to share with you how he creates reusable DataWeave scripts for healthcare acceleration. Tyler, take it away.
Welcome everyone to MuleSoft Connect. My name is Tyler. I'm a DevOps engineer at New South Wales Health Pathology, and in this session, we're going to talk about how we can create reusable DataWeave scripts for healthcare acceleration. A bit of an introduction and a bit about me. I'm a DevOps engineer at New South Wales Pathology. I started developing MuleSoft applications back in 2016, back on the MuleSoft 3.8 runtime and on the API Gateway 2 runtime. Since coming to pathology, I've had about 18 months developing MuleSoft applications in a healthcare setting. And outside of MuleSoft, I'm an advocate for infrastructure of code and hands-free deployments in our Bamboo platform. So a bit of an overview of what we're going to cover in this slide presentation. We'll give an overview of New South Wales Health Pathology's digital clinician services platform, including some of the challenges that we faced along the way, leading into the project and throughout, and what we've built on the MuleSoft platform. I'll give a brief understanding of what the differences are between Hl7 and FHIR are as a messaging standard, and how we can use the MuleSoft Hl7 EDI connector to parse our Hl7 messages in Mule4. We'll then look at how we can transform our Hl7 V2 messages to FHIR using DataWeave. And then we'll go into how we can refactor a large DataWeave script into reusable modules. And finally, we'll look at how we can use MUnit to test our DataWeave scripts. So, over the past 2 years, in collaboration with external vendors such as DXC Technology and Deloitte, New South Wales Health Pathology have embarked on a journey and discovery on how to build an integrated healthcare solution using FHIR, Hl7, and most importantly, MuleSoft. Some of the challenges that we faced leading into this project and throughout is each hospital system needs to be implemented completely differently, each with its own semantics. And there was a need for normalization of data prior to our ingestion of it and mapping it into DataWeave. We needed to ensure that all patient events are processed in the correct order. Traditionally, transforming Hl7 messages into FHIR is an extremely difficult process, especially when you're using XML path-based conversions, such as using Groovy or Java. We also needed a way to try and find how we can integrate with other cloud services, specifically for sending notifications to our end users. And finally, in the design of the solution, we needed to ensure reuse across our platform so that we can achieve reusability of the MuleSoft services that we develop, not just in this project, but in other projects as well. So what did we build using MuleSoft? Well, using a range of Azure services, such as Cosmos, Service Bus, Storage Hub, and Notification Hub, and using the MuleSoft Hl7 toolkit for message processing and for REST FHIR APIs, we were able to establish a microservice-style architecture for our integration platform. By architecting our solution using an API-led connectivity approach, we were able to build services which encapsulate the logic and normalization rules in our source systems. And here we were able to define a common model definition for our messages. We were able to utilize Azure Service Bus for our ordered message processing, and we even went so far as to build a custom MuleSoft connector in the MuleSoft dev kit. We were able to use DataWeave to transform our Hl7 messages into FHIR, and we were able to use Azure Notification Hub for our mobile application notification sending. And to this point, we even built a reusable platform service in MuleSoft. Most importantly, because each of our process layer services is fine-grained and generic, we saw reusability across our integration platform, not just in this project, but in other projects as well. What I want to focus on in this presentation is how our team have achieved increased agility in creating DataWeave modules as we build out our FHIR resources. Before we start building DataWeaves that map our Hl7 messages into FHIR, we need to understand the core differences between these two standards. Hl7 is an international standard for the transfer of clinical data between healthcare providers. Hospital systems can potentially use different systems to manage their patient admissions, their lab results, their billing, and their electronic medical record. And these systems all need to be able to communicate with each other as new information is made available. So, Hl7 V2 is the messaging standard implemented by these hospital systems, and it's designed to be an event-based trigger system messaging system with a strong focus on state machine logic that travels across the patient's journey. And when I specifically mention Hl7 in this presentation, I'm specifically referring to the Hl7 V2 messaging standard. As an example, the Hl7 ADT, or Admissions, Discharges, and Transfers message type, can capture different events associated with the patient. For example, when the patient is first admitted into hospital, or when the patient is transferred in between wards, or their information is updated, or when the patient is finally discharged from the hospital. FHIR, on the other hand, is another health level 7 standard, but it's more designed to be resource-based and designed around building application programming interfaces, or APIs, for electronic medical records. And whilst it's built on previous data definitions of the Hl7 V2 format, it's a lot easier to implement due to its core design of utilizing HTTP and REST, along with using JSON and XML for data representation. One of the main goals of FHIR is to facilitate interoperation between our legacy healthcare systems and to make it easier to provide healthcare information on a variety of different resources, allowing third-party developers to build medical applications which can easily be integrated with existing applications. Now, it should be noted that Hl7 V2 can affect, and in particular the ADT message type, can affect multiple FHIR resources. For example, the patient, their encounter, and the location where they are. So, how did pathology integrate with our core hospital systems? Let's have a quick look at this. So, in this diagram here, we have our hospital system and a very standard MuleSoft flow that what we deploy into each of our system layer adapters. So initially, the hospital system emits a Hl7 V2 message over a low-level TCP channel using the MLLP protocol, and that's minimum lower layer protocol. The MuleSoft MLLP connector receives this message over the TCP socket. And then MuleSoft EDI connector processes this Hl7 message and transforms it into a hash-mapped data structure that we can then prep and send into our DataWeave function. Our Hl7 message is then immediately enqueued onto a first-in, first-out, or FIFO messaging queue. And this ensures that our patient messages are processed in the correct order. And this is where New South Wales Health Pathology have implemented their own custom MuleSoft connector to support this. And finally, an immediate commit acknowledgement is sent back to the hospital system. This lets the hospital system know that our message has been received and that we're going to process it. Then this also allows us to provide an asynchronous message processing strategy, so messages can come in and queue up, and then we can process them as our capacity can grow and scale. And finally, once we've finished processing with our message, we can send a final application acknowledgement back to the hospital system using the asynchronous messaging channels. So let's have a look at a sample Hl7 message. And this is generated with the Happy Test Panel, which is a free Hl7 Message Editor. So this is our pipe and hat format, or our ER7 format, and we can switch between this and our XML equivalent format. And you'll notice that we have this nested data structure here, which has got our patient identifier, name, our date of birth and gender, and our address. The Hl7 EDI connector provided by MuleSoft allows us to read in that original pipe and hat format message and generate a nested hash map structured data there. So it very much emulates what we've got in the XML view, but this is more of a hash map view. And this allows us to prep our Hl7 message prior to being processed by our DataWeave scripts. And the EDI connector provides both strict Hl7 message processing, which validates against a strict Hl7 schema, and a lax Hl7 schema, which is a more relaxed version of it. So we can use DataWeave to transform our source Hl7 message into a FHIR resource. Now, whilst this DataWeave that we have on screen here is fine for a single project, or if it's only used once, it is quite large and it is quite difficult to maintain. And if we had to define a DataWeave transform for other FHIR resources that reused large chunks of code, then we would need to copy and paste those large chunks of code to facilitate that. And furthermore, as changes are made to these DataWeaves, we need to ensure that we don't introduce breaking changes. So this is where we start using DataWeave modules. So we can use these DataWeave modules to create smaller, more reusable code modules. And a module can be reused across multiple DataWeave functions, or even in other DataWeave modules. This gives us increased readability over our DataWeave functions, and it gives us the ability to unit test these DataWeave functions. It also gives us the ability to package up our DataWeave modules into a redeployable archive that we can deploy across our integration platform. And as you can see, we've already started to get some reuse out of doing this refactoring and module process in the development of this fire date from timestamp function. We can also either reuse this patient DataWeave that we've just had before in the creation of a diagnostic report resource, or we can split out our DataWeaves across multiple DataWeave scripts and bring them all back together in the end to generate our diagnostic report. And here we've got an example of using the MuleSoft context flow variables to inject our already pre-generated patient resource. Here's what an example of what this particular DataWeave will generate when given our source Hl7 message. And as you can see, the patient's name, identifier, date of birth and gender all get mapped across as we expect. We can also test each of our smaller modules in isolation using MuleSoft's MUnit framework. And here I've got a small MUnit test, which tests for all possible variations of the coded strings that get passed into our gender function. And we've also got scenarios where we can test that the expected via gender gets generated from a given Hl7 gender input. And I've also got, some other test cases there for, question marks or empty strings. So using the Mule4 MUnit suite, we can assert that each one of these scenarios passes the test and that our gender from code function works as we expect. So we're going to dive into a live demo right now. What I've got up on the screen at the moment is my sample MuleSoft project. And on the top half, we have our original DataWeave, which is the unrefactored DataWeave. And as you can see, it is quite complex. There's a lot of code going on, and it would be quite difficult to maintain this code and reuse a lot of it because it's all written in line at this point. We've already started this refactoring process, and that's this DataWeave on the bottom here. I'll just make it full screen. So we've already started to refactor the identifier, the name, the date of birth, and all we have to do left is this gender function. So that's what we're going to refactor in this exercise, in this demo. So I'm going to come over to Source Main Resources. Under Modules, I'm going to right click and go New, add a new file. And I'm going to call it gender.dataweave. So this is our gender DataWeave module. It's empty at the moment, but we are going to fill it in. I'm going to jump back into our MuleSoft code, and I'm just going to grab a copy, just by copying this to my clipboard, a copy of the gender function. There we go. And for our gender DataWeave module, we're going to define two functions. Function number one is gender from code. And this function is going to take in our coded string, like so. The other function that we're going to define in our module is gender from PID, which is going to take in our Hl7 PID segment. Now to do this refactoring exercise, this one's quite a simple one. So we have our first one is just our mapping table or mapping definition for what our gender code from Hl7 to FHIR should look like. So we're going to start with that one there. So I'm just going to cut this to my clipboard, and underneath our gender from code function, I'm just going to paste that in there. And I'll just clean up some of this formatting a little bit. Now you can see that we're still using payload data, ADT, PID, PID8. So we're just going to replace that for male. Just going to replace that with code. For female, we'll replace with code. And other, we'll replace with code. And that's it. So we now have our mapping function that takes in our Hl7 coded element for gender and returns the FHIR equivalent. Next, we're going to finish off implementing our gender from PID function. So all I'm going to do is just clean up some of this code here and just remove what's not required and just do some formatting. We're still passing in this payload, so rather than passing in the full payload, we're just going to pass in just the PID itself. And finally, we need to call our gender from code function, and we need to pass in our PID 8. And that's it, we're done. Now I'll jump back into our MuleSoft code, and I'll pull this up big screen. So now we're going to import from our modules the gender module. So let's start by refactoring this gender function, or replacing what we have with our gender module here. So because we've defined our gender from PID function, all we have to do is call our gender module and then call the gender from PID function and pass in our PID segment. And don't forget to save your files. Another really good thing about DataWeave is that we can actually generate sample data to test out our DataWeaves rather than having to run our MuleSoft application to see what our DataWeave is going to export. And I've already provided a sample DataWeave function here, a sample payload that is, that half emulates what our Hl7 message is going to look like. So we've got our PID8, which is our gender, we've got our patient name, which is Mario, and we've got our patient identifier. And in the top right corner here, we can click on the preview button, and this is going to generate a preview of what this input message will generate when run through this DataWeave. Excellent. And as we can see, we've got our Mario Bros in our name, and our gender is male. Now, we can make changes in a live environment by changing this from male to female. And now our gender has updated, and now it's female. So this is a really quick way for developers to live test their applications and their DataWeaves without actually having to spool up an entire MuleSoft runtime. Now that we have confidence that our MuleSoft application is going to work and our DataWeave is going to work, let's do a quick live test. So I'm going to hit the debugger, and I'll save my changes. And we'll just wait for the MuleSoft runtime to start up. In the meantime, I have Happy Test panel over here, and I've set up an outbound connection to localhost on port 8000, and that's what port this MuleSoft application is listening on to receive our Hl7 messages. And our Hl7 message is our sample one that comes with Happy Test panel for Dr. Mario Brothers. Okay, it looks like our MuleSoft runtime is just about finished warming up. And now our MuleSoft runtime is finally started up. So, from Happy Test panel, I can make sure that I've got the MuleSoft Connect Live Demo connection selected, and I can click Send. And that's going to send our Hl7 message to MuleSoft. And now our debugger has kicked in, and it's got a breakpoint sitting on our DataWeave. So we can inspect our payload at this point in time, and you can see we have that hash map structured data set. So under the data element, we have our ADT node, and then underneath that, we have our PID segment and all of our patient data associated with that. So now when I hit step over, you can see that our DataWeave has actually run, and it's generated the following patient resource. And again, we've got Dr. Mario Brothers, the gender of male, and a birth date, which is fantastic. Our DataWeave has run exactly as we expect it to. So some of the benefits of doing this refactoring and creating these reusable DataWeave modules. Well, one is that our functions are kept small, and the smaller that they are, the less our developers need to keep in their minds when they're making changes. We also get increased readability over our DataWeave scripts, and there's no more making changes at 2 a.m. and just glossing over pages and pages of text. By packaging up our DataWeave modules as a redeployable archive, we can then version each of our releases and safely roll them out across our integration platform, with the ability to roll back those changes if something goes wrong. And we can reuse much of this code in the development of new FHIR resources, such as the diagnostic report that we saw before. Now, all of these changes are great, but the most important thing for us is that our developers now have trust that they can reuse these code modules and expect that they're going to work. The code that we write is now much more reliable because of our rigorous testing in MUnit. And we can develop new FHIR transformations in much less time, allowing our team to focus on what's important to us, the patient. So as a brief recap from this presentation, we've given an overview of the New South Wales Health Pathology Digital Clinician Services platform, including some of the challenges that we faced along the way and what we built on MuleSoft. We also showed how we can use the MuleSoft 4 EDI connector to parse our Hl7 messages and prep them for DataWeave. We also showed how we can create transforms in DataWeave that take our Hl7 message and transform them into FHIR, and how we can break up these large, complex DataWeave scripts into smaller, more reusable components, and how we can also unit test using the MUnit framework all of our DataWeave modules. So if you have any questions, please feel free to ask them in the live chat. You can also download the sample project from this presentation from the link on the screen. Finally, thank you very much for listening to this presentation.